programming a normally closed input device. Now that we have gone over the basic bit instructions, let's review an important concept that deals with programming and that we face in troubleshooting. This is the programming of an input device that is wired normally closed to the RTB terminal of an input module, like, for example, a stop push button. Let's take a typical start-stop circuit for a motor starter to make our example more practical. When the system is being designed, or when we are adding more equipment and code to the project, we have to wire the input and output devices to the controller's I/O system via the RTBs. In this case, the start and stop push buttons would be wired to the input module's terminal, representing inputs 2 and 3 in the input module in slot 1, and the motor output wired to the output module in slot 2, to the terminal representing output 0. Assuming that we have created the tags for this motor circuit with their respective aliases, we would think that its coding in a routine would look like this, which follows the same logic as the electromechanical start-stop motor circuit and provides the desired logic continuity to the motor when the circuit is started. However, the programming of the normally closed stop push button is not correct. The stop push button should be programmed as normally open, exam on, or examine if closed to provide the proper logic continuity. To expand on this, let's think like the processor. In the original circuit, when the controller is put in the run mode, the input module will pass the status of the input field devices to the processor. And let's assume that no push button has been pressed. When the start instruction is evaluated, the status of the start push button tag is 0 or off, which will maintain the instruction open without providing continuity. When the programmed, normally closed input instruction referring to the stop tag is evaluated, the process will open the contacts, disrupting continuity, because this examine if open or examine if off instruction is looking for an open or off condition to provide continuity. However, the condition is on since the normally closed stop push button has not been pressed and is therefore providing power, or is on to the input module. Therefore, the programmed, normally closed stop contacts will open when evaluated in the code. So this motor circuit will never work in the way it's wired and programmed, although it is wired in the correct, safe manner. If start is pushed, the circuit will not start the motor because the normally closed stop contacts are open. The wired, normally closed stop push button must be programmed as a normally open, or examine if closed, or examine on in order to operate properly. Let's view it again from the processor's point of view. Assuming no push button is pressed and the controller is running, the start normally open contacts will remain open because its reference is off, or 0. The stop normally open set of contacts will now provide continuity because its reference is on, or logic 1. If the start is pushed, the motor will start because of logic continuity. The start normally open contacts will be sealed by the motor contacts so that when the start push button is released, the motor circuit is still on. When the stop push button is pressed, the input module reads an off condition, in which case it disrupts continuity and the motor is stopped. This is a fail-safe circuit because if the motor is started by the pushing of the start push button, and for some reason the stop push button wire connection to the input module's RTB is cut or disconnected, the motor circuit will disrupt continuity and the motor will be turned off in a fail-safe manner. If we had used the normally open stop push button and programmed the motor logic in this manner, the circuit would have worked exactly the same. When the start is pushed, the motor starts, and when the stop is pushed, the motor stops. However, if the motor is started and the stop push button wire disconnects from the RTB, the motor circuit will not be able to be turned off. In fact, the motor will not turn off unless the controller is turned off or put in program mode. This is not a safe situation and should be avoided. If for some reason during troubleshooting it is discovered, for example, that a normally closed stop push button is not operating properly, we need to replace it with the only available push button, which is a normally open, and change the programming of the stop to normally closed, until our replacement push button part arrives. Make sure that you document the tag to state why the change was made. For example, it is a good practice when documenting a change to edit the tag description and add an indicator like star star and then the reason for the change, then star followed by your initials, then star, and then date. The indicator can be anything. For instance, it can be hashtag and will be helpful during troubleshooting as long as all the maintenance engineering personnel uses the same indicator. In this manner, when anyone is searching to find the changes, the Studio 5000 will list all the occurrences of the indicator where the changes have been made and why.